You are moving, right now. Not just around the Sun, not just around the Milky Way. Our entire galaxy, along with dozens of nearby galaxies, is drifting through space at over 600 kilometers per second, in one specific direction, toward something. Astronomers first saw it as a simple anomaly. The cosmic microwave background, the afterglow of the Big Bang, isn't perfectly uniform. It has a dipole pattern, one side slightly hotter, one side slightly colder. That pattern means we're moving fast, roughly 600 plus kilometers per second, relative to the cosmic rest frame. The question wasn't whether we're moving. The question was, what is pulling us? At first, the explanation seemed straightforward. Galaxies don't just expand with the universe. They also deviate from it. These deviations are called peculiar velocities, the motion left over after subtracting the Hubble expansion. Measure distance, subtract expansion. What's left must be gravity. And in the late 1980s, astronomers saw something shocking. Hundreds of galaxies were streaming toward the same patch of sky, roughly in the direction of Hydra and Centaurus. It was as if an invisible mass concentration was dragging our entire neighborhood. They gave it a name, the Great Attractor. It sounded like a monster, and at first, it looked like one. Early estimates placed it tens of millions of light-years away, with a mass equivalent to tens of quadrillions of suns, big enough to bend the motion of entire galaxy clusters, big enough to explain our cosmic drift. There was only one problem. We couldn't see it. The region where the Great Attractor seemed to live lies behind the Milky Way's disk, a region astronomers call the Zone of Avoidance. Dust, stars, gas, our own galaxy blocking the view. It was the perfect hiding place. For years, the monster was inferred only through motion, not through light. Then came the first reveal. Multi-wavelength surveys, infrared, radio, X-ray, began to pierce the dust. And behind the Milky Way, astronomers found something massive. The Norma Cluster, also known as Abell 3627. A gigantic galaxy cluster sitting almost exactly where the Great Attractor was predicted. It felt like a breakthrough. The hidden monster had a face. Except it wasn't big enough. Norma was enormous, but not enormous enough to account for the full velocity of the local group. Something else was going on. Then came the first major turn. What if the Great Attractor wasn't one object? What if it wasn't a thing at all? As mapping improved, the region resolved into a network. Clusters, filaments, walls, the Hydra Centaurus complex, an extended overdensity stretching across space. The monster wasn't a beast, it was a landscape. And landscapes don't pull from a single point. They shape flows. Then the second turn, underdensities push. In gravity, we imagine only attraction. Mass pulls. But voids, regions with less mass, create an opposite effect. Matter flows away from emptiness just as strongly as it flows toward mass. Our local group isn't just falling toward something, it's also being pushed away from the local void. Suddenly, the Great Attractor stopped being the sole suspect. It became one term in a vector equation. Pull from overdensities, push from voids, tidal forces from even larger scales. The single arrow of motion fractured into components. And then the scale expanded again. Beyond the Hydra Centaurus region lies something even larger. The Shapley concentration, one of the most massive structures in the nearby universe. Some flow studies suggested that Shapley might contribute significantly, even dominantly, to our motion. The Great Attractor was no longer the end point. It was a middle chapter. Zoom out far enough, and the center moves. At small scales, streamlines converge near Virgo. At intermediate scales, Hydra Centaurus. At larger scales, Shapley. Change the smoothing lens, and the monster relocates. It wasn't fixed. It was scale-dependent. Then came Laniakea. Instead of defining structures by counting galaxies, astronomers mapped flows. Using peculiar velocity catalogs, tens of thousands of galaxy distances, they reconstructed the gravitational field. Not just where galaxies are, but where they are moving. And they discovered something stunning. Our Milky Way belongs to a massive basin of attraction, a cosmic watershed. They named it Laniakea, immense heaven, not a bound object, not a cluster. A drainage basin in the cosmic flow field. Think hydrology. Rivers converge into basins. High ground divides watersheds. In cosmology, galaxies stream along filaments into overdense basins. Voids act like high ground. The Great Attractor became part of a continent, not the whole map. Then the modern climax. In 2026, constrained simulations, digital twins of our local universe, revisited the Great Attractor idea. The conclusion? The classical Great Attractor is not dynamically dominant. Mass within roughly 155 megaparsecs accounts for only part of the local group's velocity magnitude. And even then, the direction doesn't fully align. Translation: no single monster explains our motion. Not Norma, not Hydra Centaurus, not even Shapley alone. Our 600+ kilometers per second drift is a sum. Local void evacuation, intermediate scale attraction, large-scale tides. The Great Attractor was never a beast. It was a pattern emerging from incomplete data. And yet, it wasn't an illusion. The motion is real. The dipole is real. The streaming flows are real. What changed wasn't the universe. It was our map. Each new survey, radio scans, infrared catalogs, X-ray cluster programs, massive peculiar velocity datasets, redraws the terrain. The zone of avoidance shrinks, but it never vanishes completely. Even today, parts of the sky remain undermapped. The hidden monster is partly literal. We are still filling in blind spots. So what is the Great Attractor? Is it the explanation for our cosmic motion? The present-day convergence point of streamlines? The future dynamical destination of the local group? Modern work suggests those are not the same question. And they may not have the same answer. That's the final twist. The name survived. The meaning evolved. Step back. The Milky Way is not stationary. It is not central. It is not drifting randomly. We are embedded in a layered gravitational landscape, pulled by clusters, pushed by voids, tugged by tides from structures beyond our best-mapped volume. The Great Attractor was never a singular cosmic monster waiting to consume us. It was our first glimpse of the hidden architecture of motion. A sign that the universe isn't just expanding, it's flowing, and we are part of that flow. Far in the future, in some simulations, our local group's motion trends toward Virgo on cosmic timescales. But even that is possibly to be changed, because every time we widen the map, the center shifts. The Great Attractor wasn't the end of the story. It was the beginning of cosmography. We thought we were asking, what is pulling us? The deeper question turned out to be, how does gravity sculpt motion across hundreds of millions of light years? The monster dissolved. The architecture remained, and we are still moving. right now, toward a gravitational landscape far more intriguing than a single word could ever capture. If you want to keep exploring the hidden structure shaping our cosmic path, subscribe, because the universe isn't just expanding, it's alive with motion, and we're riding the current.